So in this question, we see that there are a number of graphs: speed and time, position time squared, and velocity time. So there's a lot of things going on here. All right, so we have an object undergoing, so we would have to do Oizurga for all of them. Let's see if we can understand what's going on now. Object undergoes acceleration as it travels along a straight horizontal track. As it travels, so that means that the initial velocity is greater than zero. Whether it's speed or zero, it's not zero. So let's see if we can use that to help ourselves, that first fact. Well, this first choice says the speed at time zero is not zero. And if we look again at the speed on the velocity time, the fourth graph we have here, it says that the velocity is not zero and stays constant. And it says it undergoes acceleration. So right away, we now know that it can't possibly be this one, because this first one would show that it has constant velocity, the one that we just colored. All right, so what do we see happening in, and so this first graph shows that the speed is increasing. Now this graph here, if we look at it, the slope, we can read position and time. The slope, or the gradient, is delta x over delta t, which is the velocity. And the slope, in this case, is constant. So this is a constant slope, constant velocity. It can't be this one either. And we're asked to select two answers. So we know it's this one and this one. By elimination, we can get to these two. But if we wanted to verify that this one, this last one is actually also true, we can look at our equation that relates position when something is accelerating, and that is this formula. So we have an initial position of 0, and we have x equals 1/2 at squared. Now, if we tried to turn this into a line, we would be looking at something like y equals, we want this to be somehow like y equals mx plus b. And so if the y-axis is position, the x-axis is time squared. So the slope would be equal to 1/2 the acceleration. And so we are looking at something that the position is kind of proportional to the time squared. Now, it's a little more complicated than that because there is an initial velocity. But we see that if we linearize this graph holds in terms of the units and dimensions.